x into, the other one is cos x plus 4 sinh x. Then in the denominator it is all. So you'll be told to prove the hyperbolic identity of squared x plus 3 sinh 2x plus 8 sinh squared x all over cos squared x plus sinh 2x to be equals to 1 plus 4 times x. So we start from the left hand side, we get what is on the right hand side. So here, if we investigate what is on the right hand side, it's a simple angle times x, isn't it? So the first step is to get rid of the double angle. Are you seeing that? You get rid of the double angle. So the double angle here, sinh 2x is the same as sinh x plus x, isn't it? So in hyperbolic, that is going to be sinh x cos x plus, in hyperbolic everything was direct, isn't it? Plus sinh x cos x, isn't it? So that one means it is the same as 2 sinh x cos x. So when we have sinh 2x, we're going to put 2 sinh x cos x, isn't it? Same here, it is the same here, we substitute with that, isn't it? So, can you substitute that? So here, where we have, this is 3 into sinh 2x, and sinh 2x we found is the same as 2 sinh x cos x, then this sinh 2x we found is the same as 2 sinh x cos x, isn't it? So that is now what we have. We have to move with it until we find that it is the same as 1 plus times x, isn't it? So from there we now have, open the bracket here, we have cos squared x, 3 times 2, 6, plus 6 sinh cos x, isn't it? Then plus 8 sinh squared x, isn't it? Then all over cos squared x. So you can see cos x is a common factor, isn't it? So if you factorize out cos x, you will remain here with cos x plus 2 sinh x. So if you investigate, you can check if you can get this factor from the numerator, isn't it? If you can get a factor like cos x plus 2 sinh x, because this looks like quadratic identity, isn't it? So if you take here 6 and 8, the sum and the product. So if you let cos x to be y, isn't it? If you let it to be y, it's like you have y squared plus 6 sinh xy plus 8 sinh x squared, isn't it? Isn't that? So from here you can say a product of 1a times, isn't it? So a product of 8 sinh squared x and a sum of b, which is 6 sinh x. Can you get them? 1, 4 and 2. Yes. You see that 1, 4 and 2. So the product here is 4 sinh x and 2 sinh x. If you add 4 sinh x and 2 sinh x, you get a sum of 6 sinh x, isn't it? And 4 sinh x times 2 sinh x, you get 8 sinh squared x. It is working out, isn't it? So can we now do that? It is 4 sinh x and 2 sinh x. So if you factorize that numerator, you get cos squared x plus 4 sinh x plus 2 sinh x cos. Then the rule of this is having cos x, isn't it? Then, if you open it, let us just open it to minimize space, isn't it? So that is going to be 4 sinh x cos x plus 2 sinh x cos x, isn't it? Plus 8 sinh squared x. Then everything is over cos x into cos x plus 2 sinh x, isn't it? So collect the common factor here is cos x, isn't it? So if you remove cos x here, you get cos x into cos x plus 4 sinh x, isn't it? Good. Then the last two terms here, the common factor is sinh x, isn't it? So if you remove sinh x, no, not sinh x, it is 2. 2 sinh x is the common factor there, isn't it? If you remove 2 sinh x outside, you remain with cos x plus 4 sinh x. If you remove 2 sinh x outside, isn't it? Then all of this is over cos x into cos x plus 2 sinh x, isn't it? Open that bracket, close that bracket, cos x plus 2 sinh x into the other one is cos x plus 4 sinh x. Then in the denominator it is all over cos x into cos x plus 2 sinh x, isn't it? So which one cancels out? This one cancels with this, isn't it? So what do you have here? So you can now see what you remain with here. Cos x over cos x is, because this is a common, this is cos x. This is cos x over cos x, isn't it? So if I write it up here, let me write it up here for you to see it clearly. What are we remaining with in the numerator? In the numerator, we are remaining with cos x plus 4 sinh x, isn't it? And in the denominator, we are remaining with cos x, isn't it? So that is what we are remaining with. So that is a common. It's a common denominator, isn't it? So common denominator will imply this is cos x over cos x, then plus 4 sinh x over cos x. So cos x over cos x is 1, isn't it? Then plus 4 sinh x over cos x is tan x. And you found whatever was on the right hand side, isn't it? You just apply the appropriate methodology which will enable you to get the proof for the given identity.